All right, guys, we have this video here for the practice test for Unit 6. Question 1. We have three numbers here. It's going from a positive to a negative to a positive, so we know that there can't be a common difference. We know it's going to be a common ratio. Again, if you try to do a common difference, 24, take away a negative 48, that's really 24 plus 48. Which is a huge number. But then if you go negative 48 plus 96, it's not that same number. So obviously this is not a common difference. It will be a common ratio. So we're going to pick a number and divide by the previous number. So that's 24 divided by negative 48. That reduces down to negative 1/2. If you actually divided 24 by negative 48 on a calculator, it'll give you a negative 0.5. You should recognize that that's a negative 1/2. If you did it with the other two terms, negative 48 divided by positive 96, negative 48 divided by positive 96 on a calculator, it'll also be negative 0.5, which is also negative 1/2. So we are certain that we know the common ratio is negative 1/2. So with that said, we could get from one term to the other by simply multiplying 96 by negative 1/2. That'll give you negative 48. If you multiply negative 48 times negative 1/2, that'll give you positive 24, and so on and so on. Now they want us to find a sub 10. So if you get a calculator and you multiplied negative 96 times negative 0.5, hit equal, it'll give you negative 48. And I believe if you hit equal again, it'll give you 24. And if you hit equal again, it'll give you negative 12. If you hit equal again, it'll give you positive 6, and so on until you get to the 10th time. That's how to do it manually. I don't recommend doing it manually. I recommend using the a sub nth rule of a geometric sequence. So let's write down the a sub nth rule right here. A sub n equals a sub 1 times the common ratio r to the n minus 1 power. So what is a sub 1? That's 96. What is the common ratio? We said that was negative 1/2. And we do have the power of n minus 1. And this is your a sub nth rule. And now, once you have the a sub nth rule, that's the function that produces any number on your list, you could plug in that 10 that they want you to plug in. So here's the notation, a sub 10. That has nothing to do with the math. That's just stating that we're about to plug in 10 into the actual function to get the 10th term on our list. So let's actually do that. We have a 96 times negative 1/2 to the power of 10 minus 1. So you are not going to multiply first. You have to do exponents first. And even before doing exponents, you got to do this 10 minus 1, which is an exponent. So that's going to be a 9 right there. If you want, replace 10 minus 1 with the 9. And on a calculator, you could do negative 0.5 to the power of 9. Now, if you have a Texas Instrument calculator, it's not going to give you the fraction. If you have a Casio calculator, you will be able to hit the fraction button, the SD button, and that will give you the fraction negative 1 over 512. Another way of doing this is recognizing that a negative number to an odd power, right? A negative times a negative is a positive. So if you had an even power, then it would be a positive value. But because it's odd, it's going to still stay negative. Okay, so what if you were to put the 9 on the 1 and the 9 on the 2? All you really have to figure out, 1 to the 9th is simply 1, and it's going to stay negative because it's odd. But the 2 to the 9th power, that's what you need to figure out, which is 512 if you did that on a calculator. So what we have here is 96 times negative 1 over 512. Okay, so we need to multiply that by 96, right, on a calculator. If I just have this on the calculator and multiply it by 96, it'll give me the final answer, negative 3/16. Okay, and right here in the instructions, it says if you get a fraction like negative 3/4, type it in like this, negative 3/4 with no spaces between your terms. So what is the answer? There it is. It's what we just found, negative 3/16, negative 3/16, negative 3/16. And that's how you do it. Let's move on to the next one. So we are here on this second question. It's asking us again to find a sub 10, the 10th term on the above sequence. So let's do that. So let's find, obviously there's no common difference. 3 take away a fraction is going to give you, well actually 3 take away 1.5 is 1.5. And if you do 3 halves take away 3/4, it's not going to be 1.5. So it's not a common difference. It is a common ratio. Let's actually write out our work here. 3 divided by 3 halves. 3 divided by 3 halves. That's really 3 times the reciprocal, 2/3, which is really the answer 2, okay, because the 3's technically cancel out right there. Now let's do 3 halves divided by 3/4. 3 halves divided by 3/4. You could keep the first fraction, 3 halves, change it to multiplication, flip the second fraction, make it 4/3. And again, the 3 and the 4, that when you divide by a fraction, you flip that second fraction and you change the division to multiplication. And then you could cancel out the 3 with the 3, and then the 4 divided by 2 is also 2. 4 divided by 2 is 2. So as you can see, we do have a common ratio. Common ratio is 2, okay? What is the a sub nth rule for a geometric series or sequence that has a common ratio? A sub n equals a sub 1 times r to the n minus 1 power. A sub 1 is 3/4. That's the first term right there. R is the value of 2. The common ratio is 2. And we have to the n minus 1 power. And this is your a sub nth rule, which produces any number on your list. Now they specifically want the 10th number. So here's the notation. A sub 10. That has nothing to do with the math. That's just saying that I'm about to plug in 10 into this machine, the 3/4 times 2 to the 10 minus 1 power. So that's really a 3/4 times 2 to the 9th power. And let's do this math on a calculator. 2 to the 9th power is 512. So we have 3/4 times 512. You could just multiply top with the top, bottom with the bottom, and you'll have 3 times 512 equals 1536 on a calculator over 4. So if you try to divide 1536 divided by 4, that'll give you 384. And that's what you're going to be typing in as the answer. 384, right there. Let's move on. They ask us to find the a sub nth rule of this sequence, and then after you find the a sub nth rule, find the 57th term. So do we have a common difference or a common ratio? Let's start with the difference to see if that works. 2 take away a -1, that's positive 3. Let me write that down. And then we have -1 take away a -4. And as you can see, that also equals 3. And likewise, a -4 take away a -7, which is also positive 3. So what do we have here? We don't have a common ratio. We actually have a common difference, which is 3. The common difference is 3. Okay, so that means that it's arithmetic. And what is the rule, the a sub nth rule to an arithmetic? It's a sub n equaling a sub 1 plus parenthesis n minus 1 times the common difference d. This one does require work. It's a little bit more challenging than geometric a sub nth rules, because geometric, you just plug it in and that's it. Right here, we're going to plug in the common difference 3 right there. And we do have the n minus 1. And we also have the plus and the a sub 1 term, which is -7, out here in the front. Okay, so we have a function that needs to be simplified. Let's distribute -3 times n. That's actually, I said -3. It's positive 3 times n. It's positive 3n. Positive 3 times -1 is -3. We do have a plus sign, and we also bring down the -7 in front. And we can now combine the first term -7 with the last term -3. That will give us a -10. And notice that I wrote it in at the back because I want to write this 3n out here in the front. So there's my positive 3n right in front, and then -10 at the end. And of course, we still have this a sub n equals. Here's my equal sign. Here's my a sub n. This is my a sub nth rule for this arithmetic sequence. Now they want us to find the 57th term. Okay, so I want to go with the calculator. The calculator is easy. All you got to do is, this is the notation, a sub 57. That has nothing to do with the math. That's just noting that you're about to plug in 57 into this function. Here it is, 3 times, we're plugging in 57, and then subtracting 10 at the end. Now with the calculator right now, as I'm speaking, I'm typing in 3 times 57. I hit equal, it's 171. Take away 10 is 161. So 171 take away 10, I just did it on a calculator. The final answer is 161. So there's my answer. Your answer, you have to type it in, and that's what we have over here. Answer is 161. Find the a sub 7 term of the following sequence. Well, is it arithmetic or is it geometric? Let's find out. If I do negative 24 take away 36, let me actually try that. Negative 24 take away 36, we're going to get a negative 60. If I do 36 take away a negative 54, 36 take away a negative 54, that's going to be 80, that's going to be 90. So there's definitely not a common difference. Let's try a common ratio. Negative 24 divided by 36. Negative 24 divided by 36. I'm going to do that on the calculator. I mean, I could write it as a fraction and reduce by 12, but actually I should do that, right? Oh, calculator. I'll know I'm not making any mistakes. Negative 24 divided by 36. The answer is negative 2/3. Negative 2/3. Negative 2/3. So it looks like my common ratio is negative 2/3. Let's just verify that. Let's go 36 divided by negative 54. 36. So it wasn't a common difference. I just want to verify that we do have a common ratio of negative 2/3. 36 divided by negative 54 on the calculator. 36 divided by negative 54. It's also negative 2/3. Okay, so we know for a fact that the common ratio is negative 2/3. So because there's a common ratio, we know it's geometric, and we would like the a sub nth rule for this geometric sequence. The a sub nth rule for a geometric sequence is a sub 1 times the common ratio r to the n minus 1 power. And of course the common ratio is negative 2/3, so I'm going to put a negative 2/3 inside my parentheses. My a sub 1 term is negative 54, so this a sub 1, I'm going to write, that's my first term, which is negative 54. And of course we have to the power of n minus 1, and this is your a sub nth rule, negative 54 times negative 2/3 to the power of n minus 1. And I love geometric because you don't have to distribute, you don't have to combine like terms. You just plug in your a sub 1 term right there, your r right there, and you're done. This is the machine that produces the list. This is the function that'll give you any number you want. Now, they want you to do a sub 7, okay? So let's actually plug in, or write the notation a sub 7. Has nothing to do with the math, that's just the notation saying that you're about to plug in 7 into the function. So we have, what happened there? Hold on a second. My bad. Negative 54 times negative 2/3 to the n minus 1, but we said we're plugging in 7. 7 minus 1 power. So what we really have here is negative 54 times negative 2/3 to the 6th power. So with the Casio calculator, it's pretty easy because you could actually type in fractions, and I'm going to go negative 2/3 to the 6th power. It's going to be positive because a negative term to an even power is positive. And on the Casio calculator, you will get 64 over 729. And you still need to multiply that by negative 54. So now let's say you don't have a Casio calculator where you could actually type this in and then hit to the 6th power. What you could do is rewrite it on your paper as 2 to the 6th over 3 to the 6th. And then do each of these on your calculator. 2 to the 6th will give you 64. 3 to the 6th will give you 729. Okay? And remember, remember that a negative number to an even power is positive. So if you don't have a Casio calculator, just distribute that power to the numerator and to the denominator. Do the math separately. It's a positive 64 over 729. And we are multiplying by negative 54. On the calculator, you just type it in on the Casio, and it'll give you your final answer of negative 128 over 27. That sounds confusing, and it says right here if you get a fraction, something ridiculous like that, and that's exactly what we got. It says type it in as the negative numerator slash the denominator with no spaces between your terms. and that's what we got here. So apparently I made a typo right here. Don't worry, it'll be fixed. It's negative 128 over 27. So cancel that out. Here's your answer, negative 128 over 27. This is your correct answer. Moving on. Use the a sub nth rule to find a sub 49. So once again, we are going to find if there's a common difference or common ratio. I always like starting with the common difference. Let's see if it actually works. 15 take away a negative 9. 15 take away a negative 9. That is 6. No, what am I saying? 6. 24. 24. Okay, so what if I did negative 9 take away negative 9 take away negative 33? It's going to change it plus plus. And just to be safe, I'm going to do this on the calculator. Negative 9 plus 33. I messed up. Negative 9 plus 33 is positive 24 as well. So we know that it has a common difference of positive 24. What does that mean? That means that from here to here, I add 24. If I did negative 33 plus 24 on a calculator, it will give me negative 9. Negative 9 plus 24 on a calculator, it will give me 15. So 15 plus 24 will give me the fourth number, plus 24, fifth number, plus 24, sixth number, plus 24, seventh number. You want to go all the way to the 49th number. So obviously you don't want to do that on a calculator. That's going to take you too long and you'll probably make a mistake. So what we want to do is write the a sub nth rule of this arithmetic sequence because it's a common difference. We know it's arithmetic. So let's write down the a sub nth rule of an arithmetic. A sub n equals a sub 1 plus parenthesis n minus 1 times that common difference d. And a sub 1 is the first term of the list right here, which is negative 33. We do have the plus sign because it's arithmetic. We do have the n minus 1. And now let's get the common difference, d, which is 24. So I put times 24 over here. And we still need to clean this up. We need to distribute and combine like terms. 24 times n is 24n. 24 times negative 1, that's negative 24. Bring down the negative 33. And then combine the first one with the last one, and that'll be a negative 57. So I want to put the negative 57 over here at the end, and the 24n right in front of it. So my a sub nth rule really is equal to 24n minus 57. Now again, if you're not too comfortable with the work that you just did and you wanted to verify it, go ahead and plug in a 1 and see if it gives you negative 33. So 24 times 1 is 24. And then minus 57, when you hit equal on the calculator, it really will give you that first term, negative 33. If you plugged in a 2, it'll give you the negative 9. Plug in a 3, that'll give you the positive 15. So we want to go all the way to the 49th term. So here's the notation, a sub 49. It's nothing to do with the math. It's just the notation saying that I'm about to plug in 49 into my function. So here it is, plugging in 49. You still have minus 57 at the end. So please use a calculator. 24 times 49, that's a huge number, 1,176, minus 57 on the calculator. The answer will be 1,119. So the answer, you could type it in with a comma, but I know some people get confused with commas, especially when we have commas on our sequences. So you could type it in 1,119 or just 1119, and that should be correct. Either one should work. Let's move on to the next question. This one's kind of silly. Whoops, let's pretend we did not see that answer right there. This one's kind of silly because it says the above summation problem is arithmetic. Of course it's arithmetic. It's in the form of a variable k that's being multiplied by a number and addition or subtraction. That's like a line, right? Y equals mx plus b. We know it's arithmetic. If it were geometric, you would have a sub 1 times r to the n minus 1 power. So you don't obviously have any exponents here, so this is arithmetic. Anyway, we know that it's arithmetic. They want us to find the summation, and in order to do this, you got to recognize first that summation means, the sigma notation means summation, and then you got to know which formula to use, which is going to be the summation formula of arithmetic. That's S sub n equals n, how many numbers you actually have in your list, times a fraction, and in that fraction on the numerator, you are adding your first term, a sub 1, with your last term, a sub n, and then you're dividing by 2, okay? So there's the formula for summation of an arithmetic. which is completely different than the formula of summation for a geometric. Anyway, let's jump right in. Let's first find out how many actual numbers, do we actually have in this series, in this summation problem. We have 9 take away 1 plus 1. So that's a total of 9, all right? Total of 9 numbers in your list. You could actually write out your entire list of 9 numbers and then add them up. Your first number would simply be to begin by plugging in the input 1 right in there and doing the math. 6 times 1 is 6, and 6 minus 34 with the calculator. 6 minus 34, to not make mistakes, is negative 28. Okay, so when I plug in 1, right, I take that 1, plug it in, do the math on a calculator, I'll get negative 28 as an answer. So this is my first term, which I need right here, a sub 1. Now we need our last term, and again, this process is plug in a 1, plug in a 2, plug in a 3, 4, 5, 6, 7, 8, until you get to plugging in 9. That'll be the last number on your list. In this case, the 9th number on your list. So let's actually write that out. 6 times 9 minus 34. That's going to be 54 minus 34, which is the number 20. Okay? So the last number, the a sub nth number, is 20. And now we have all the 3 things that we need to use the summation formula. We have how many numbers there are. There's 9. We know the first number is negative 28. The last number is 20. And we're ready to go. So let's actually do this. Let's plug in the summation of how many numbers do we have? We have 9 numbers. So the summation of 9 numbers, that's just the notation. It's not actually the math. It's just the notation that we're actually going to add up all the 9 numbers on this series, this arithmetic series. We do have n, which is 9. There's 9 numbers, times a fraction with up on top we have the first term, a sub 1, which is negative 28, plus the last term, which is positive 20, and then we're going to divide it by 2. So when I actually do negative 28 plus 20, that's negative 8. So negative 8, and it is over 2. We still have the parentheses, and we still have the 9 out here in the front. Now inside the parentheses, negative 8 divided by positive 2, that's a negative 4, and a negative 4 times 9, that is a negative 36. So your answer is negative 36. There it is. Negative 36 is the correct answer to this problem. Now, if you actually wrote out all 9 numbers of your list and then added them up, because sigma means addition, right? You would first have your, actually I want to pause it and I'm going to figure out that list. Check it out. Okay, I instantly did this, but it actually took me a long time to do, right? I plugged in 1, got negative 28. Plugged in 2, got negative 22. Plugged in 3, and I got all these, and I counted 1, 2, 3, 4, 5, 6, 7, 8, 9. I know there's 9 numbers on the list. Now, if I actually went through and added all of these numbers, add all of these numbers on a calculator, it will give me the answer negative 36. Okay, so obviously doing this method is a waste of time. I recommend finding your first term by plugging in 1, getting that number, finding your last term by plugging in 9, getting that answer, and finding how many numbers you actually have on your list by doing 9 take away 1 plus 1. 9 take away 1 is 8 plus 1 takes you back to 9, so there's a total of 9 numbers on your list. Plug it into your summation formula. First number, last number goes right here and right here. And of course the number of numbers, 9, is right there. Do the math, you'll get negative 36. It's way faster than doing this long waste of time that I did earlier. But you didn't actually see that because I hit pause. So it wasn't long for you, but it was long for me. Okay, sorry about that. Let's move on. Find the summation of this. Okay, so whenever they say find the summation, we know we're going to be using an S sub n formula. The question is, do we have an S sub n formula for an arithmetic, which means there's a common difference, or S sub n formula for geometric, which means there's a common ratio? And obviously, you can see that there's a common ratio here. 32 divided by 16 is 2. 16 divided by 8 is 2. It's good to write it out also, right? 32 divided by 16, that's 2. 16 divided by 8, that's 2. So we know that the common ratio is 2, which makes this geometric, which means we can now use the formula a sub 1 minus a sub 1, your first terms, right, times r to the n power over 1 minus r, or you could also use S sub n equals a sub 1 your first term minus a sub n your last term times that common ratio, which in this case is 2, over 1 minus r, that 2. Anyway, let's use that. Here we go. We have a sub 1, which is 8. We have a sub n, which is 4,096. And we have the common ratio, which is 2. So let me make a little bit of space here. Put times 2 over 1 minus that common ratio 2. Now, if you're wondering, why did he use this one instead of that one? Well, to use the top one, yes, you need to know your a sub 1, your first term, which we do know is 8. But you need to know your r, which is 2. But you need to know n. You need to know how many terms there are on the list. I don't know how many there are. Right here I see 1, 2, 3, but there's a lot of numbers missing till you get to 4,096. So you need to know n to be able to use the first formula. Since we have the first term and the last term, I used the second formula, the first one and your last one, common ratio. You have everything you need. I've plugged it in. Now let's work it out. So let's start. Again, PEMDAS is the correct order of operations. That's multiplication before subtraction. So let's multiply on the calculator 4,096 times 2, and we'll have 8,192. So we have 8, take away 8,192. Again, I just did this part first. I multiplied and I got this answer. And I also brought down the 8 and the minus sign. There it is, 8 and the minus. And now we have the division bar, and 1 minus 2 is negative 1. So for the final step on the calculator, 8 take away 8,192. That'll give you negative 8,184, negative 8,184 divided by negative 1, which gives you the final answer, the summation of this many numbers. I don't even know how many of the numbers there are, but I do know it will be positive 8,184. Positive 8,184. Let's check that answer by moving this out of the way. There it is, 8,184. Notice this one, it didn't have a comma. That's totally fine. You don't have to put a comma. This 8,184, that's 8,184. It's a correct way to write numbers. But I know some of us get confused with the comma. You might think it's like a sequence or something. So it doesn't matter if you use the comma or if you use a comma or not. Either way, the answers should be correct. And this is the correct answer right here, 8,184. Okie dokie. So we have this one. This is a summation problem as well. However, this is the interesting part. It does not start at 1. If it started at 1, yes, you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 until you get to 20. So you'd have 20 terms in your series. Why do I say series? Because sigma is summation, and a summation is really a list of numbers that you're adding together, which is a series. Anyway, first question is this arithmetic or is it geometric? Remember, arithmetic, when you have a common difference d, and, well, let me just write it. Arithmetic is a sub 1 plus n minus 1 times that common difference d. And of course, when you plug in your values, you distribute, you combine like terms, and then you end up with something like this, 7k minus 17. But instead of k, you'd have an n. But this is an arithmetic series. Now, what if it were geometric? What would it look like? It would look like this. A sub n equals a sub 1 times that common ratio to the n minus 1 power. And notice that you don't have anything to a certain power, especially with a variable up here. So if this said like 7 to the k minus 1 power, then you know it would be geometric, right? But because you don't have any powers with the k in the power, then you know it's arithmetic. And as I'm explaining that to you right now, I realize that that whole segment is pointless because on the instructions it says above summation is arithmetic. Yep, that lesson right there is to read instructions before thinking. Okay, so we know it's arithmetic. Why? I mean, you could have used that rationale, but because they tell you it's arithmetic. Okay, so we know there's a common difference. But more importantly, we know that we need to use the summation formula for an arithmetic series, which is n times the fraction a sub 1 plus a sub n divided by 2. Again, remember, a sub 1 is your first term, a sub n is your last term, divided by 2. And n is the number of numbers, okay? So let's walk through this. Let's find our first term of this specific series. Now, How do you find your first term? Well, you plug in 1, and then how do you find your second term? Plug in 2. But remember, right here, they don't want you to start with 1. They want you to start with 7. So your first term, your first number of your specific series will be plugging in 7. So you're going to have 7 times 7 minus 17. 7 times 7 minus 17, that's 49 minus 17. So that would be 32. So your first number is 32. This is your first number, which goes right here. So let me start the formula again. We now have a 32 as our first number, and we're going to add it with a sub n, the last number. Okay. What is the last number? For the last number, we're going to take the 20 and plug it right in there. So that's going to be 7 times 20 minus 17. So that's going to be 140 minus 17, which is going to be 123. So the last number here is 123. Doing the math. So we have 123. So this last number right here, 123, I'm going to plug it in over here into, well, that messed up, in here into the last number, which is going to go right there, obviously. Divided by 2. And what else do we need? We need the number of numbers, okay? So how many numbers do we actually have? This is where you take the top number 20 minus that bottom number plus 1. 20 minus 7 plus 1 is 14. 20 minus 7 plus 1 is 14. So we have a 14 out here as your n. Okay, you could write that down. N equals 14. Why? Because 20 minus 7 is 13 plus 1 is that 14 right there. N equals 14. If you're thinking, well, why do you do 20 minus 7 or plus 1? Again, if you start on the 7th number, how many did you skip? You really skipped 6, right? You skipped 1, 2, 3, 4, 5, 6. So it's really the total 20 minus 6, which is 14. But the easier way to do it is just this one minus that one plus 1 will give you the number of numbers on your list. Anyway, we now have the math problem. 32 plus 123, that's 155. It is divided by 2, and we do need to multiply it by 14. I see that 14 is divisible by 2. I'm just going to divide 14 divided by 2 and get a 7. So my final answer will be 7 times 155. And the answer is 1,085. 1,085. Man, this is a giant mess. I wrote all over the place. I am sorry. Let's double check our answer by moving this. And there it is, the correct answer, 1,085. It doesn't matter if you use a comma or not. 1,085 is your answer, just like we said. Alrighty, let's move on to the next question. We have another summation problem. And again, summation is S sub n, but we need to know which formula we're going to use. Is it arithmetic or is it geometric? It is obviously arithmetic. If you go -1, take away a -4, let me actually show that work. -1, take away a -4, that will give me a +3. Or you could do -4, take away a -7, which also gives you a +3. So we know that the common difference is 3. Okay, the common difference is 3, +3. That is very important bit of information there. What else do we know? We know that a sub 1 is -7. Okay, that's a sub 1. And we also know a sub n is 89. Okay, so because this is a common difference, because it's arithmetic, we're going to use the formula, the summation of n equals n times a sub 1, your first term, plus a sub n, your last term, divided by 2. So what is n? I do not know, but I do know my first and last term. So let me at least put my first and last term right there, the -7 plus 89 divided by 2. Now I still need n. I don't know n. Okay, so what am I going to do to solve this problem? Let's jump to the a sub nth rule. Okay, so I'm going to go to a sub n of this arithmetic, which is a sub 1 plus parenthesis n minus 1 times that common difference d. And again, I do know a sub 1 is negative 7. I do have plus n minus 1. I don't know n, so I just leave it n. Times the common difference. We said the common difference is 3. This is the a sub nth rule. Okay, I might as well simplify this a sub nth rule, distributing 3 times n, that's 3n. 3 times negative 1, that's negative 3. Bring down the plus, the negative 7, and I might as well combine the negative 7 with the negative 3, giving me a negative 10. So I have 3n minus 10 with the a sub n as the name of this thing. It's the a sub nth rule. Now, they did not ask for the a sub nth rule. They did not. However, we need it. And why do we need it? Because as of now, if I simply had a number for a sub n, I could plug in that number right here, and then I could solve for n. That way I'll know how many numbers I actually have. That way I could use the formula that I wanted to in the first place. So what am I going to do? Where am I going to get this number from? Well, what does a sub n actually mean? A sub n actually means your last number, right? It says right here, a sub n is 89. So what I have here is, let me write it, 89 equals 3n minus 10. So if I solve this thing for n, plus 10 cancels, plus 10, that's going to be a 99 equals 3n, and I'm running out of space, so I'm going to write it over here. 99 equals 3n, and if you divide both sides by 3, you'll get n equals 33. So we know now for a fact that there's 33 numbers, okay? There's 33 numbers. So let's actually plug in that value of 33 into our formula over here. So we have 33 times negative 7 plus 89. I might as well do that on the calculator. Negative 7 plus 89, that's 82. Divided by 2, it's going to be 41. So I really have 33 times 41. 33 times 41 on a calculator is 1,353. 1,353. Okay, that is your summation. So if you actually took a calculator and went negative 7 plus negative 4 plus negative 1 plus 2 plus 4 plus 7 plus all the way to 89, hit equal on your calculator, it'll be 1,353. And as you can see right here, the answer, 1,353, with the comma or without, either way is acceptable. I hope this explanation helps.